here if anybody else needs to grab a book. As you guys are working on your review, what do you get to save time on? Directions, problem details, just show me the work that gets to answers. Sound good?
Yeah.
And I think also the answers for the review are in the back of the book, so you guys can be making sure you're getting them right. The review is homework tonight. Hopefully we'll have the majority of class time to work on it, but before I totally let you go, let's go ahead and grade section 2.7. So section 2.7, we'll get all the way to those last couple problems where it got weird. We'll pop over, Sophia asked if we're taking notes, we'll pop over to that, like, hey, how do you find domain of square root things? That was where homework got weird, I think. We'll pop over, make sure we know what's going on. Oh, hey, 61 was one of your homework problems. Look at that, ready to go. Then I'll let you loose on reviewing after we talk about some details of the test. So, here we go, section 2.7, number 2. Key numbers and test intervals. Number 12. Number 12, they got common denominators to make one nice big fraction. They got common denominators to get one nice big old fraction. That was one way of doing it. If you got common denominators, put it together as one big fraction, you would have gotten all the key numbers of the denominators, -2 and +1, the undefined points, and then also the numerators, 1 and 4.
Did you ever grade 2.6? No.
We didn't grade 2.6 at all?
No.
We haven't graded a lot.
Yeah, we've been behind on grading.
Yeah,
Okay, let's keep grading 2.7 then. Number 30, your key numbers were 0 and 3. The one that was true was 3 to infinity. The key numbers were 0 and 3. The one that was true was 3 to infinity.
Oh.
Because you had to test all 3. The other 2 would have been false. Number 46, your key numbers were the denominators, 6 and -2. But you also would have needed to find -14, which you could have just solved, or they did this crazy common denominator work, which also worked. But you could have also done cross multiplication, moved everything to one side. You would have also found the -14. Those are your 3 key numbers, and if you guys can tell, they did like the chart method where they split it up into all the different intervals. Bless you. Bless you.
Gracias.
And the true ones were these 2 here at the bottom. Jaden.
How did they get to 2x plus 28?
Oh, well, remember, they subtracted him to the other side and got common denominators.
Oh, so you just...
But you didn't have to do that. You could have done what we did yesterday where you just would have solved. And to solve, that's what I was just saying, is that you could cross multiply. So you could do 3 times x minus 6 on one side, 5 times x plus 2 on the other side.
Okay. And that's how they get 2x. So they just combine like terms like this.
Yeah. Combining like terms should have gotten that -14. I'm just peeking at it real fast. Because that would have been 28, and that would have been -2x, which would have gotten you -14. Yeah. So that would have been a lot faster.
Okay.
They just did a really snazzy common denominator trick. Well, remember, you have to look at your, bless you. I need to get rid of my cross multiply. You have to look at your inequality. Was I allowed to be at, well, first of all, am I allowed to be at the undefined points? No. So 6 and Alex? Okay, sorry, both of you.
Oh, sorry.
6 and -2 are both undefined. So Emily, first of all, we can't be there because they're DNEs. So those are always going to be open. But then if you look at your inequality, this also says that zeros are not allowed or solutions are not allowed. So we have to go ahead and make everybody with open because zeros aren't included with the just greater than. Does that make sense? Yeah. So if it's just greater than, then everything's open. If it's greater than or equal to, then the solutions can be closed, although the DNEs will still be open. The DNEs will still be open. Number 66, key numbers were from the top 0 and from the bottom ±3. So you should be able to see that indicated, and they aren't showing the table in a nice big old table, but they're basically showing all the information. And they're plugging in and seeing, hey, for a test point, does it work or does it not? So which ones? -3 to 0 was true, and 3 to infinity was true. They included 0. Emily, you see it? Or equal to. So the 0 was needing to be included, whereas the undefined points, plus or minus 3, nope, still excluded. Okay, it doesn't help you guys with the domain question. 61 wasn't an even, right? So you couldn't have graded it. And some of you got stuck at 61. So domains are weird just because they aren't fractions. Like, I thought the whole section was fractions. Well, no. But what we do say for square root functions is that the underneath part. Oh, yes, 4 minus. Oh, it is the one way? Okay. Okay, second? Yeah. My domain says this dude needs to be greater than 0. Whenever I have a square root greater than or equal to 0. I'm allowed to have 0 and I'm allowed to have positive numbers. So if I need that bottom part to be greater than or equal to 0, well now, guys, do you see why this is in this section? That's a nonlinear inequality of section 2.7 at its core. So we're going to go ahead and figure out our key numbers, which go ahead and factor this dude. That'd be 2 minus x, 2 plus x. So x equals plus or minus 2.
So, like, you would just keep it as it looks instead of, because, like, when I think about it, I would, like, flip it and it'd be negative x squared plus 4. But you can't do that.
Not in a way that's going to be helpful, unless you rewrite it as because then you could do x plus 2, x minus 2 with a negative outside. That's technically going to be okay.
Okay, so when you see something like that, then I can just do it as it is, just 2 minus x plus.
Yeah. That's the easier way, because anytime you have an a squared minus b squared, you can factor. So I just didn't want to.
So my brain like automatically like tries to flip it.
Because you want the x. Whereas in math, it's common procedure if there's a minus to try to put the positive guy first. You don't learn that when you're learning like algebra 1 standard form. Sophia? Oh, well, I haven't answered the problem yet. Hold on. Because we just have the key numbers. So if you're going to your number line, then we're going to have to check what's going on in this interval, that interval, and that interval. If you're going to your table, we have our negative infinity to negative 2, our negative 2 to 2, our 2 to infinity. Emily, am I doing parentheses or brackets? A little bit of both, because of the So I'm going to be allowed to put brackets on everybody, because none of them are DNEs. Well, the infinities, they always have parentheses. If I need a test, right? So I could test something like negative 3. Does it work? Does it not? I could test something like 0. I could test something like 3. So if I plug in negative 3, you could plug it in way back here. 4 minus 9. Is that good or bad? That's like undefining, so forget him. He's not even real. If I plug in 0, that's good. And if I plug in 3, 4 minus 9 again, that's bad. So therefore, what's my domain? -2. Okay, Sophia, go ahead. What was your question? That's going to be a case where, like what Jaden was saying, if it was x squared minus 4, which it's not, but if it was, this wouldn't be the true one. These would be the true ones. And so then if I have more than one answer, instead of putting the word and, instead of putting a comma, they use the snazzy symbol, the U instead. But you could also just put a comma in between and say, like, if these had been true, you could have said this guy, comma, that guy. I would take it. But the U is just a snazzy way of saying, hey, here, or technically, or here.
When you write your answer, is it okay to write it as x is greater than or equal to -2 and less than
The inequality notation? Yeah. Just Cassie, you would just want to be aware on the test if it was like a multiple choice answer, you need to know that that is a party.
It's not for me, I promise. It shouldn't be.
Huh? I do. Just email me or something. I can figure out what's good. Alright guys, so we've graded, we're going to keep grading too, kiddo, so that way we can check out the video grade. Let's go ahead and that's 2.7, let's go grade 2.6, 2.5, 2.4, whatever you need. So, going back, what's the next homework that's not graded? 2.6? Yeah.
Can you go over 12, sorry, on 2.7?
After we finish grading. Okay. So 2.6, number 2 is vertical asymptote. Number 8, now they have like crazy tables and ridiculousness going on. Remember, you were just trying to figure out what's going on towards the asymptotes, right? And so as you were going in towards the asymptotes, there are different ways that you guys could have done it, but one way, oh, I can't do it because my board's not working. We'll do this. Maybe you guys used all these words, but maybe you didn't. If you were approaching -2 from below, if you're approaching -2 from above, I don't know if you guys did graphs, I don't know if you use words, I don't know if you use the snazzy notation. But we have x, f of x decreasing without bound as he comes in towards -2, so that would be he's going to -infinity if you were doing it that way. If you're coming from the right, he's increasing without bound, which means f of x is going to +infinity. So however you wrote your answer, there are multiple different ways. Using words or using notation, using graphs. As I come in towards +2 from the left, if I was coming a little bit below, my f of x is approaching from the left -infinity or decreasing without bound. As I'm coming from the other direction, f of x is approaching +infinity. Does that kind of make sense? Sorry, the book looks super complicated with all the words, but we're just getting the other ones. Number 12. Vertical asymptote was -3/2. Horizontal asymptote was -7/2. There was a tie. Ratio of the leading coefficients. Horizontal asymptote, there was a tie. Vertical asymptote, he was non-removable, so I had to use that 0. Number 22. Domains everything but 1. At that 1 is a vertical asymptote. Horizontal asymptote, the degrees are tied, 3. X-intercept, you just have to plug in y is equal to 0. Y-intercept, plug in x is equal to 0. And then they just do a little table to try to put together some more information, but long story short, you should have gotten a swoop, swoop with a vertical and a horizontal. It was a swoop, swoop. But you wouldn't have known this swoop unless you plugged in a few extra points or unless you knew what was going on towards the vertical and horizontal asymptote. Huh? Swoop. We have A, we have C, we have B. With matching. We have A, we have C, we have B. With matching. And then number 60 was one of those, like, just graph it. And to just graph it, well, we just went through all the characteristics again. Domain, everything but 2. But after long division, that's not a whole. It doesn't reduce away. It's a vertical asymptote. So I knew vertical asymptote 2. I knew no horizontal asymptote, but what was there? slanty one. Because when we divide and there's a line left over, he's our slant asymptote. Now they got a few extra points, which to be honest, was pretty disgusting because they have some nasty fractions. So you might not have needed all those extra points. But when they put together all of their pieces as far as their y-intercept, as far as their asymptotes, if they had just gotten like a couple here and a couple there, swoop, there it is, and swoop, there it is. Had to be in between the vertical and slanty asymptote, had to be in between the vertical and slanty asymptote. And that point said, okay, here he is, and then there he is. Once again, they did a few extra points. You did not need to do that many. No, sadly it's not a parabola because it's kind of skewed because it's going straight up that way and it's going sideways that way. And parabolas, remember, go out forever, whereas this one's stuck. Weird, right? Those ones are stuck. Then you got true, true, false. At the end? Yeah. True, true, false. Okay, I know we have number 12 on section 2.7. 2.6, we might have a couple questions. Does that mean we didn't grade 2.5 either? Oh, we did. Okay. 2.6, I think, was the day I was gone. You guys were finishing it, and then I just went straight to 2.7 yesterday. Sorry about that. So before we go to section, actually I'm already in 2.7, so let's go peek at that number 12. If you want to. If you don't want to, that's okay. You could be playing with your review. That's totally fine. You could be playing with your review. That's totally fine. But then I'll see if you guys have any questions on 2.6. Jaden, help me out. What were the directions on number 12?
I'm trying to think of the way that went. I have directions over 5. Where does it start? Oh, there it is. Okay. Finding key numbers.
Oh, just key numbers.
Okay.
With key numbers, remember with rational functions, we're looking for zeros and then undefineds. The hard part of this one is it doesn't really give us another side. With zeros, I mean, we could kind of make our own other side.
So key numbers are, what do you mean when you say undefined?
Oh, domain problems or discontinuity.
Okay, so that would be,
So
can't be
yeah.
-2, can't be 1.
So I can do that right away.
Okay. That's what I did, but I don't know. I didn't know where you are.
Because then we're looking for these. Now, on the other ones, we have like an equals, and so it's a little, or we have like a less than, so it's a little easier because we can move. But zeros are the other solutions if it's written for us, or zeros if it's not. So at that point, I would have, this is probably what messed you up, is not having this. Then I would have cross multiplied to get x squared minus x equals 2x plus 4. Move it all to one side.
So 4 and 1. So
Oh, plus 1. Sorry.
So when you're trying to find key numbers, you need to cross multiply.
You want to solve.
So if it's like that, how it's something over something,
Then you can
have to cross. Okay.
Well, it's probably the easiest. You could have also done the whole right? You could have done it that way. It would get you at the exact same place. So you would have had to multiply by the x plus 2. So you technically, if you just go the algebraic route, you would end at the same place. Cross multiplying is the shortcut. Is there anything else from section 2.7 you guys wanted to say? 17. Okay, that was an actual solving. You have a couple options on 17 for the key numbers. The problem is, well, actually, I guess maybe not so many options. This one's weird because you might have gone factoring it right away, but the problem is the 9. If it's like a rational function where I can multiply to the other side and play with it, that's one thing. But it's a quadratic, I need to factor to find the zeros. For quadratic, I only know how to do zeros. Meaning, I need to move that 9. If I can get him equal to 0, then my factors mean something. If you factor up here with a 9 on that side, so get a 0 and then factor. Then we would get plus 5 minus 1. And we're solving this one, but I'm just doing the key numbers first. So my key numbers are going to be x equals 1 and negative 5. So they're the zeros. Okay, so now I need to take this off to the side. So I have my x plus 5. X minus 1 greater than or equal to 0. I have my... Megan, which way makes more sense? The number line way or the table? Okay, so then I'm just trying to figure out true or false. So then I would try maybe like a negative 6. And then maybe like a 0. And maybe like a 2. As our test. You could go back here and try plugging in. My brain gets a little lost here. I kind of like just plugging in here. Because then I can say negative 6 plus 5 is negative 1. Negative 6 minus 1 is a negative 7. And negative times a negative works. So I like kind of just doing signs and not worrying about numbers. But you could have gone here too. If you plugged in negative 6, it would be a true. If you plug in 0, that's a negative number, which is false. I'm doing mental math, careful, but 0 would be false here. 4 is not greater than or equal to 1. And then 2, I think, is also a positive. 2 would also be a true. So then we just have to think about what Emily asked. Do we keep the intervals open or closed? Now, that's negative infinity to negative 5. Parenthesis or bracket. Well, look at our inequality, right? Closed means or equal to. And then I'm allowed to have this guy too, which is a 1, 2. And Sophia, there's just that snag. I'm just connecting because both of those are true.
What does it mean?
It means or, technically. Yeah. Whenever you were graphing like these little number line dudes, you would always have to use the word or if they weren't overlapping, and the word and if you were overlapping.
And the bracket determines because of the or equal.
And if it was just greater than, we would just have parentheses.
And what tells you that it's coming from negative infinity?
I didn't make my table, so I was looking at my number line. If all of these numbers, remember intervals say how left to how right.
Is it because that's true, so it has to?
And how left it goes is negative infinity. How right it goes is,
Negative 5.
and then how right, how left, sorry, how left, and then how right.
Okay.
Anything else from 2.7 that you guys missed? 2.6?
For 2.6, yeah, when you're, I think it says to find the intercept.
Oh yeah, it's a part of like the longer problems to do the intercepts. Those got kind of nasty. That would be here, huh? In the 17 to 40 stuff. I think it said for letter B, all the intercepts. Do you have like a specific one you were like, this is gross? 19. So they weren't very specific, but when they say just find intercepts, they mean the x and the y. So we just kind of have to remember that x-intercepts are when y is 0, which remember, that's the same thing as this little function do. So f of x or h of x or whatever. So I'm going to do that by setting the whole thing equal to 0. And we'll solve that in a second. But the other types of intercepts are the y-intercepts, which is when x is 0. So I just need to find, plug it in. So then that one's kind of a little bit nicer, because then I just need to simplify. which means I have the point, which I'm going to take to my graph eventually by doing 0 and right. But over here, it's like up. Well, my advice is always multiply, because you have to somehow break this up. But the problem is on this one, when I went to multiply, doesn't it just become 0? That's not right. This guy, whoever he is, he has the vertical asymptote. The bottom wins, so he has a horizontal asymptote. This guy must not, I'm just guessing real fast, Megan, but I'm pretty sure it's the graph. This guy must never hit the axis. And that's our way of seeing it, because it's just as we're working on the review, is there anything that you guys have got?
Oh, yeah,
7? Ooh, this is back to quadratics and parabolas, huh? So I'm thinking, to do what they're asking us to, I'm thinking that completing the square might be nice. Yeah. So completing the square, well, okay, hold on. Isn't there a formula for vertex technically?
HK.
Yeah, H equals, do you remember what the H equals? Like the little baby formula that's kind of cheating, but it does work.
Negative.
Negative B all over 2A, right? Well, if H equals negative B all over 2A, technically, if they want this, if you forget like on the test, now you do need to know what standard form is, right?
Yeah.
But you could technically be like, okay, well I can kind of cheat and figure out H without completing the square. Negative B all over 2A. So I can actually get the y equals x plus 1/2, x minus a negative 1/2. Now, hold on, we need to fill in an A and we need to fill in a K. Okay, wait, A is always ax squared plus bx plus c. That's why it's called A. Well, that's nice. I need a K. Wasn't the K just the y value? The y value with the x value of h?
So 13.
Can't we just plug it in? I wish it was 13 if x was 0, but he's not. But I could plug in what he is. That's somebody like, hey, please just tell us how to complete the square because we don't want to do this. But if worse comes to worse, you could plug in negative 1/2. You would have 4 times negative 1/2 squared plus 4 times negative 1/2 plus 13. That's 1/4 times 4 is 1. That's minus 2. 14 minus 2 is 12. That's it. That's one way. That's one way. But that's using the formula trick because you didn't know how to complete the square. If you know how to complete the square, instead he would have taken this whole thing and said, hey, let's get a leading coefficient of 1. But remember, the 13 has already been rejected. He's off to the side. So I only take the 4 away from both of the x squared and x terms. I take the middle coefficient, I cut him in half, and then I square him. Middle cut in half squared would end up being 1/4. But why am I going to put a negative 1 out here in the blank? Has to be negative because it has to be opposite. And the 4 times 1/4 needs to be offset. So 4 over 4 is 1. I needed a negative 1 to offset that. But then all of a sudden, check it. So all I have to do is x. Remember the trick? You get to steal this dude every time. And then In my mind, it's a lot easier, but it's still kind of tricky. So. Yeah. Good question. Complete the square is the right-hand side. And then the little shortcut formula is the left-hand side. Speaking of which, some of you guys might want to kind of know whether or not you actually have to complete the square on the test, right?
Oh, yeah.
You want to talk about the test?
Yes.
Okay. You can open up your notes, you can open up your homework files, wherever you want to write some hints to yourself. You can open up your notes, you can open up your homework files. Wherever you want to write some hints to yourself. Okay, you have about 17 multiple choice. Then you have like 4 long answer, enough 3 long answer. In multiple choice, you could be asked to find, well, first of all, multiple choice, I don't think you're required to complete the square anywhere there. So that's questions like vertex, find the vertex, find the standard form. Hey, kind of like the one Sophia just brought. Kind of like, hold on, section 2.3 factoring and finding zeros. Remember, 2.3 was easier than 2.5. 2.3, there were like GCFs. But finding zeros, factoring like 2.3. Like 2.5, factoring a nastier polynomial when given a solution. If they say, hey, if this is true, go find all the rest. If you know one solution of a polynomial, what's the very first thing you should do? Synthetic, divide, make it smaller, then finish. So they kind of do part of the work for you. Ooh, right-hand behavior and left-hand behavior. If you have an odd polynomial, how's he going? Opposite, right? We have to think of, okay, positive leading coefficient or negative leading coefficient. If you have an even, how are they going? Together, either positive or negative. A little bit more factoring. A synthetic division one, like what happens if you do a synthetic or a long division? What would the answer be if you divide? Complex numbers, how to find like A and B. Ooh, that's a lot like a homework problem. You guys didn't like it, we're going to put a question on it. How to find like an A and B for A plus BI. How to make a square root of a negative into an imaginary number. How to multiply or divide complex numbers to make them look like A plus B.
Wait, can you say the thing before that again?
How to rewrite a square root of a negative with an imaginary number. Like, what's the square root of negative 144? 12i. Like that.
The one after that one.
Then multiplying and dividing complex numbers. That was like the end of that homework. Finding vertical asymptotes, VAs. Finding horizontal asymptotes, HAs, degree Fs. Wait, hold on, vertical asymptotes. Are they all the zeros of the denominator? Or can anyone else be down there?
It's what makes it zero.
Is what makes it zero after you factor and reduce. Gotta get rid of the holes first. So factor and reduce, then look for your VAs. Factor and reduce, then look for your VAs. Intercepts. Hey, Megan, great question. What if there's a nasty rational function like section 2.7 and they just want the intercepts? Would you know what to do? Solve a rational inequality. It's in the multiple choice section, like section 2.7, a top and a bottom with a less than, greater than, less than or equal to, greater than or equal to. You know what to do. Long answers. You ready? There are 3. Show me you can do long division. You're welcome. Show me you can do long division. Factor a nasty polynomial completely, finding its zeros with no hint. That's like section 2.5. polynomial, you gotta factor. P.S. Start by listing the possible next zeros. Plus or minus factors of the last over plus or minus factors of the first. And then, third long answer is like section 2.7. Solve an inequality, but it's not a fraction. It's just a polynomial. And the bonus, oh, I can't tell you the bonus. Well, the bonus has something to do with proper notation. So not using words, but using arrows, if that makes sense. The bonus has something to do not with using words, but with using arrows. Guys, I think I pretty much literally gave you all the topics.
Thank you.
So you know what to find. And I gave you hints about what homeworks to go look at for sample problems, right? If the review doesn't give you any, just like it. We have about 5 minutes. You guys just keep working. There's one place, literally, one question you're going to really want to use your calculator. I'm going to play with it just for a second and make sure that's fair for me not to. Oh, I have these little baby calculators. Don't worry. Hey,
Baby calculators.
So if you want, you can grab a little baby scientific calculator to have at your desk tomorrow for the one question with addition and subtraction and craziness that you would want to solve. Sound good?
Yes.
Maybe calculator.
The only struggle is
Baby.
shouldn't even let that. Hold on. I'm gonna go back to my desk with the whiteboard. There's a reason why it's non-calculator, but even with that, it's... Yeah, remember it has to be non-calculator because otherwise you could just graph every single one and find the zeros of every single one on the graph. Playing with your window a lot, but I have no idea if you actually know how to factor or not. Check out the multiple choice because it's a multiple choice question. If there are no I's present, then none.
So if don't write it.
Oh, this is for sketching the graph, right?
Yeah.
Yeah, then none, because you wouldn't be able to show it on the graph. Does that make sense? Okay, I'll let you have the little baby scientific calculator, but to get full credit, if the directions say to use something in particular, and remember, I did not say that about completing the square, but the directions say to use something in particular, like synthetic division, you'll have to actually do synthetic division for me to give you the full points.
Banana.
Kiddos, I do have to go to Kaiser today for an appointment on my toe. Make sure it's all healed up above my foot surgery a couple years ago. Long story short, I'm not here after school, but I am here during lunch. I will be here during period 7, at least most of it come at the beginning. Or I will be here at the beginning, like early tomorrow, between like 7 and 7:30. If you want to pop in and ask me a last minute question. Okay?
But why?
If you do come in just kind of wanting some random practice, I do have some just practice problems on cards that you could try and then flip over and see if you get it right. I do have some practice problems on cards, just little ones like find the vertex or factor or divide, simplify. So if you come in, you can try some practice problems with me, but remember, not after school, sadly. Lunch, period 7, or tomorrow morning.
No.
Okay, like, if you know it's easy,
Let's do. I know two.
You know 2?
Two.